This high school math class is reviewing concepts about graphing and quadrants in order to begin the day's activities.
Now when we put a point, when we plot a point, we're looking for the x and the y coordinates. So our x and our y in quadrant 1 are what values?
Positive.
Positive, positive. And in quadrant 2, they're what values?
Positive, negative.
Negative, positive. You can speak up. In quadrant 3, they're what?
Negative.
Negative, negative. Very good. And in quadrant 4?
Positive, negative.
Positive, negative. You guys did good. You remembered all that. This is all stuff that you have to know to be able to do today's lesson. So this memory bank of things that we've been learning all along are necessary for you to be able to follow and do today's lesson. The activity starts with the students doing a review of what equations are in the Cartesian plane and just basic information of the Cartesian plane. And then we go into manipulating equations and changing an equation into slope-intercept form and then matching a graph to that equation. Then we went from there to graphing our own equation, and then we did an application of that in a tutorial through Green Glob's computer program. From that, we went to an internet project, and they gathered data, and they're going to create their own graph from that, and then they'll do a journal entry.
The teacher presents the first group activity that will help students practice their ability to identify slope and intercept.
This is a graph that I have made the line of, and then I'm going to give you one equation. Okay? Your graph and your equation do not match. In just a moment, once everybody gets theirs, I'm going to let you get up and you're going to find who has, and you're going to trade so that when you get finished, your graph and your equation match.
Students compare graphs to find the right matches.
Once you find yours, have a seat. If you want to double check with me, I'll tell you who's right.
After reviewing the correct answers for their matching activity, students break into small groups and become experts at one equation. The groups then rotate so that students can teach each other about slope and intercept.
Don't do it right there. You're going to do it right here at the 6x and then on the other side of the equal sign.
I was wondering because your y got to be positive. You can't end up
That's right.
negative y. So it'll be 3y negative 12x equals.
Now how can that be negative 12x? You want to zero this out, right?
Also, we're going to add 6.
Very good. Now put it over here. Write it over here.
It should be 3.
No, go ahead and finish writing it. Write it all out. Write it all out.
Write all what out?
6x.
Oh, okay.
Okay. That's not going to make 12. That's going to do what?
0.
Okay, so zero it out. Now you have what?
3. 3y
Equals.
3.
Equals.
3.
No. This has x's and this doesn't. You can't put them together, remember?
Okay, so then you got to divide, don't we?
No. They're just going to go over there.
Okay.
So you're going to end up with 3y equals a minus 6x plus 9.
Okay, I get you.
Are you with me now?
I'm with you.
You have to move it.
You didn't subtract your 6 from there. Did you? Subtract your 6 from there? Well, this guy knows these ones, so I'm listening to Andy. Let's check. That's what I done right there. Alright, let's see.
The teacher circulates throughout the room to answer questions and remind students of their tasks in the group.
How are we doing over here? You guys are 3s. What did your equation end up as in slope-intercept?
Y equals 2x minus 3.
Very good. Everybody agrees? Okay, then go ahead and do your graph. Some of you are still trying to skip steps, and you know that when you go back and you try to look at your equation and see how you arrived at what you ended up with, when you got to your slope-intercept form, when you haven't shown your steps, then if somebody's going to go back and double check you, then they're going to have to do the whole problem also. If your steps are written out there, then they can very quickly scan down through your steps and they can see if it's done correctly or not.
The groups work together to graph each equation on their graphing calculators. The teacher then encourages them to explain each graph's slope and patterns that emerge during their group activity.
Now when you move on down and you do y equals x plus 2, what can you say different about x plus 2?
I know.
They're parallel, but they are different intercepts. Why are they parallel? They have the same slope. Very good. You see, those are some things that I wanted you to see. Any two lines that have the same slope are going to be parallel. They're just going to be scooted up and down that y-axis. Very good. What about y equals negative x?
Negative.
It has a negative slope.
Same as the one above, just different direction.
Oops.
Negative slope.
I put
That'll be what the intercept.
That's not good.
Okay, so it has negative slope. Is it parallel to anything?
No.
No. Is it perpendicular to anything? Be careful.
Before entering the computer lab to work with graphing software, the teacher instructs the students on aspects of the program Green Globs.
From linear quadratic, then you're going to go to the top bar again and click on linear quadratic, and today we're going to be doing lines. Now I want you to start with easy and work to hard ones. There's going to be 20 levels. Listen very carefully because this is how you're going to do your record keeping.
The teacher then explains how the students will keep track of their scores during the game based on how well they can write equations through given points. She also assigns an internet project using the web to gather information about automobile depreciation that will be graphed using linear equations.
I'm also going to give you your internet lesson. You're going to go to a website and you're going to gather data about the depreciation of automobiles. I'm going to let you select which automobiles you want to do. So you're open in that respect. You get to pick which ones you want.
Once in the lab, students work individually or in groups to play the Green Globs game. The teacher monitors the students' work and answers their questions.
No. Your 5 was right. You counted. Okay. Okay. Listen to Amanda. Say it again.
Over 4. 1, 2, 3, dot 4.
You do your rise. No. You do your rise over your run. Now imagine a line through there. Where would you want it to go?
But through here.
Okay. Hand me a piece of paper and I'll show you something. You can use the edge of your paper as the imaginary line. Oh, your screen has good static too. Now write the equation for that line, and it doesn't have to hit them exactly. I think I could do better. I think that'll get all 4 of them, won't it? It's close. You just have to graze them. There's 1. Can you get those?
No, I doubt it.
1, 2, 3, 4. Oh, that one's out of pocket. You could drop it down to the bottom edge of those and get that one and get 5. Try it.
Which one are you talking about? That one?
Go like this.
See, you can't get that last one.
Can I not just graze the edge of it and get that one right there too? Or is that one out of pocket?
You might.
Well,
no,
you don't know till you try. Try it.
See,
Try it.
look, that one's on this. Which one you trying to get? That one, and that one?
Yes.
You can't, because those two are on the same line. And you can't go like that.
But all I have to do is just barely touch them. I don't have to go through the center of
But I
them.
doubt if you could.
Try it.
Because I was hoping it's going to go from like
The bigger your slope is, the closer it's going to be being vertical. Okay? You're getting there, but let's just pretend that these were 2 points on my line. If I went from that one to that one, I would have a slope of up 1 over 1, right?
Over 1.
But if I'm going from those 2 points that I want to hit, I'm going up and over how many? Count it.
up 4. Over 9.
9?
I guess.
Okay,
so.
put 9. Now, don't go yet. Where do you want it to cross the the y-axis? Where do I want it to come across there?
Right here,
Probably at about 2.5. Try it. Oh, you need a operation in there.
Nope, ain't working.
Now, look what you did. You told it to go at positive 2.5. You want it down here at... Okay, you got...
You can get 4, but that's about it.
No, you can drop it down and get this one.
I don't know. Then you'll probably miss that one.
Okay, can you change your slope a little bit and get those two instead of that one?
Probably.
Okay, adjust your intercept and work with your slope and see if you can get some more.
The teacher concludes the lesson by assigning a journal entry discussing the day's activities.
Right now, I need for you to take your papers. You need to leave with me your green globs paper. If you want to take your internet lesson to finish your graph and questions, you may do so. I have a journal entry. You're going to now answer some questions about the things that you learned. Explain to me what slope means to you. How is it used? Why do I have to know it?